Hey guys, welcome to your very first video of the year. This is not new, so I'm not going to waste your time on all the introduction stuff, but I do want to talk about that I am going to be doing things a little differently in chemistry this year. So if there's anything that you are super confused on or you don't understand, please stop me and please talk to me so that I can make sure that that stuff is clear for you. Just like with every video, I always add the objectives. So after this video, you should understand why measurements are useful in chemistry, define and use SI units, convert numbers to scientific notation, distinguish between precision and accuracy, and convert units using dimensional analysis. This particular video, this information is number heavy. And in all the classes I teach, chemistry is super important, or numbers are super important in chemistry. And so we are going to spend some time doing conversion factors and doing some math. So please make sure you are ready to put in some work if you're not super strong in math. All right, so what are measurements? Measurements are values that we use to indicate size in some way. And so, for example, you've probably heard of 12 meters or 12 yards or 12 eggs. Anything can be a measurement as long as it's a quantitative number to tell you how much you have. Now, what I want to make very clear with measurements is the fact that you have to use some type of tool to actually measure something. And you have to have more than just a number to actually measure something. So, for example, if I say the number 12, you don't know what I'm talking about. I could be talking about 12 inches, 12 centimeters, 12 yards, 12 miles, 12 kilometers. You have no idea. So until I put a unit to something, you really don't know what I'm talking about. But the moment I say I have 12 gallons, now you know I'm talking about a liquid. Or if I say I have 12 inches, you know I'm measuring the length or width or height of something. So those are ideas, those are concepts, that I want you to become very familiar with when we talk about measurements. Accuracy and precision, which we'll talk about here in a little bit, are super important for this class. Also, with measurements, we use specific tools to make sure we're measuring as accurate as possible. And these tools help us measure things like volume, temperature, mass, length, anything that you can think of, we have a tool to measure it. And the more precise and accurate you are, the closer you are going to be to the true value. And we're going to talk about some of the tools that we use to measure volume, temperature, and all of those in class later. What I want you to also understand is in the lab, we will always be measuring macroscopically. And what I mean is there are big things that we can see. So if I'm measuring 50 milliliters of water, I can actually see 50 milliliters of water. So that's a macroscopic level. Microscopic level, when we want to measure how many atoms are in a specific thing, we have to calculate that using theoretical numbers. Theory, but they still have been tested and validated. A good example I have on here is that 15 centimeters is a measurement. So in that idea, you're probably measuring a piece of paper or something smaller but not super large, maybe even some glasses, anything like that, or your phone. The next introduction we're going to talk about is SI units. So in this class, we are taking the idea of the English units of measurement out. You will never use inches in this class. You will never use anything that has to do with the English system. So pretty much everything you're used to, you got to relearn something new. And the reason we do that is because the SI units are much easier to use when it comes to conversions. For example, if I gave you a really large beaker and I said, here, measure out 10 milliliters, it would be really hard to do if you didn't have the conversion factors. So we are going to practice this on converting from one unit to another, but I just want you to become aware that these are the two tables that we will use. You will put these in your notebook in the next couple of days, so please be ready to do that. We are going to walk through this slowly. I shouldn't say slowly, but we are going to walk through it. So SI units are a revised metric system used in science in particular. The reason why we use it is because they're easily convertible due to the powers of 10. For example, I could say I have 1 kilometer of something. Well, kilo, the prefix kilo, tells me I have 1,000. So I could also say I have 1,000 meters or 1 kilometer. Those equal the same value. And hopefully when we talk about this in class, it'll be a little more not basic, but it should be a little more clear. Right now, when you're looking at these two tables, they're a little overwhelming. So whenever we talk about different units, if I say we're measuring for length today, then you would need to use meters. And sometimes it's hard to measure using a whole meter, so you would convert down to centimeters or millimeters. And you're gonna see what I mean. You guys did a lab over this last year, but no big deal if you don't remember. We're gonna practice that again. The other one I want you to notice is that here, for temperature, we're using Kelvin, but it's really hard to measure in Kelvin. So when we do this in the lab, we'll typically just deal with Celsius. Time is in seconds. Mole is the amount of substance. Electric current and intensity we're not going to deal with too much, but we're going to spend quite a bit of time using the meter, kilograms, Celsius, and seconds, and mole. And then over here on this table, you'll see we have prefixes. These are fantastic to use. Any test in the future that you'll ever have as far as like things for college and things like that will use prefixes. So if you know the value of a prefix, then you already know what you're kind of looking for. What I want you to notice here is there's no prefix for this guy. So that means we just have one of something. If I say I have 1 meter, I just have one. But if I say I have 1 kilometer, I no longer just have one, I have 1,000 of the base. And again, we will spend time talking about that. So please, please, please don't get overwhelmed just yet. Like I said, we use this to convert back and forth. And basically all you're doing is you're moving your decimal back and forth. I'm not going to do that here because I don't want to take up all your time. But in class, that's how we're going to start talking about these conversion factors, or excuse me, these SI units. In this class, we are going to deal with really large and really small numbers. You can see here, I went ahead and edited this slide. I made a mistake on the PowerPoint and I didn't go back and change it. So I'm gonna just edit it here. So when we use really, really big and really, really small numbers, we are going to use a method, or not a method, excuse me, a writing notation known as scientific notation. And what this does is this takes away this makes really, really large and really, really small numbers into a more readable, easily understandable number. And why we do this is just to eliminate the idea of mistakes. If you have to type in 20 zeros in your calculator, that can be very difficult to keep track of. So I want to make sure that we are able to do scientific notation. And how the form looks for scientific notation is you have an integer from numbers 1 through 10, and then you have a power of 10, and then an exponent. So it would be like, let's say that's the integer, so let's say it's 5, times 10 to the whatever power. Now, a couple of things I want you to understand. This number here, this capital N, should always be a number between 1 and 10. It should not be 563 because that's not 1 through 10. It should be like 5.68. That is a number that's 1 through 10. Your 10 power doesn't change. The lowercase n is an exponent, obviously, and it can be positive or negative depending on which way you moved your decimal. So I'm going to do this example for you and show you what I mean here. Let me erase this. So I converted 56,862 to scientific notation. And so how did I do that? What I did was I took my decimal, and actually I'm supposed to actually have this decimal right here. Sorry, I forgot to put that in. So now instead of 56,000, I have 568.62. My apologies for that mistake. So in order to make this number a little more readable, and I know you're thinking like that's the hundred, so it's not hard to read, but this is good practice. We're going to start with something simple, and then we're going to work our way into more difficult numbers. What I'm going to do is I'm going to make this decimal move so that I am in between two numbers to make a number, to make a number in between 1 through 10. Now, the next question is, well, how do you know which way to move your decimal? You're always going to move your decimal to the first two sets of whole numbers. So when you're reading this, you would see 568.62. You're going to move your decimal in the direction of the first two whole numbers. So in this case, I'm moving my decimal this way, so to the left, 2 times, in order to be in between the first two whole numbers. So now in scientific notation, this number here is the same as this number, but it's a little easier to read and interpret this 5.68 times 10 to the second. Now you're probably like, that is not a hard number. So if we tried another one, I can't erase that. I don't know why it's not letting me erase that. It's fine, we're fine. So let's say I had 5, 4, 3, 2, 1.6, and I wanted to convert that to scientific notation. Again, I'm gonna move my decimal so many times to get in between this 5 and this 4. So here's my decimal, 1, 2, 3, 4. So I've moved it to the left 4 times. So that's gonna be 5.4 times 10 to the positive 4th. So how do I know it's positive? Because this number here is greater than 0. We are going to talk about what greater than 0 and less than 0 look like in a bit. I know that's like as clear as mud, but I promise as you practice this becomes much easier. All right, another important concept when it comes to measuring is the idea of accuracy and precision. So when you are accurate, that means you are close to a measurement's true value of the quantity measured. So accuracy is defined as how close a measurement is to the true value of the quantity measured. Precision is how closely two or more measurements of the same quantity agree with one another. So I've given this really nice example of accuracy and precision using these dartboards. Now I want you to notice when you're throwing darts at a dartboard, you always want to hit the center. That is the most points. So that is our desired quantity. Our true value would be the center for here. So if you notice here, this guy here, we have just a mess. We have everything everywhere. So this would be an example of low accuracy, low precision. We are not clustered anywhere. We're not close to the bullseye that often. We got it one time out of the 6 times we shot, or excuse me, the 7 times. So not very accurate, not very precise. If we look over here, now notice these bullets, or not bullets, these dots are close to each other. So the measurements are close to one another, but they're not close to the intended target. So this is a good example of high precision but low accuracy, where I can get them all together, but I cannot get them to the intended spot. Over here, these are not clustered together. They're a little more spread apart, but they're pretty close to the bullseye. So in this idea, we're high accuracy, whereas we're getting close to the bullseye, but we're low precision because we're not clustered together. And then here is our idea of a perfect game, where we have high accuracy and high precision. The final thing that we are going to talk about, and this is something we will spend days on, so please be ready to commit some time into dimensional analysis. This is probably, and I don't want to scare you, but this is probably one of the harder topics, but we are going right into the mole and mole conversions right after this unit, so it's very important that we know this right away. Dimensional analysis is the process used to convert between units. So for example, if I say I have 3 inches of something, and then someone asks, well, how much is that in centimeters? I need to know how to convert that. And so how I do that is using conversion factors. This is an example of a conversion factor where these 2 values equal each other. So if I say I have 1 inch, I can also say I have 2.54 inches. So if I have 3 inches and I want to know how much that is in centimeters, I would use this conversion factor to figure it out. Now we're going to do this in days and everything else. I'm setting this up and we're going to walk through how we set these up in class. So don't worry, I'm just setting it up. I'm putting it over 1 so that way everything's in fraction form. And I'm going to multiply some things. Now in math, what I want to do is I want to know how much 3 inches is in centimeters. Like I want to know how many centimeters are in 3 inches. So I need to cancel out this unit and go to my desired unit, which is centimeters. So I want to go to centimeters. I need to cancel out inches. So anything on top of each other will cancel out. My conversion factor, which I already told you is right here. So 1 inch equals 2.54 centimeters. So I would just multiply 2.54 times 3 equals, and I didn't do that math on my paper, so I apologize. But whenever you solve that, you would get that number in centimeters, and it'd be like 7 or something like that. Nope, that's wrong. It's fine. It's fine. The other thing I want to talk about is a lot of you are going to be like, well, that's dumb because I can just figure it out in my head. That's great, but when I ask you how many atoms are in 13 liters of of water, you're going to be like, I don't know how to do that. That's why we're practicing dimensional analysis. Right now, you can do the problems in your head, and it's great. When we get into talking about moles, it's not going to be so easy. So practicing dimensional analysis now will be super, super beneficial for you in about a month or so. So please don't come at me that you can do this in your head. Practice how we do it in class so that you're ready for when it gets harder. All right, with that being said, that is a lot of information. We will talk about all of this baby step by baby step. If you have any questions, please make sure to ask me on Edpuzzle.